These are your 2-2 solving one-step equation notes. So in this section, probably a lot of review, just like the last one, but bringing us all up to speed. We are going to solve equations by using inverse operations. So we're either going to add or subtract or multiply or divide, only one step. So I know you guys know how to solve equations for the most part. So the focus here is going to be on showing extraordinary work, being very neat and organized in our workmanship. So to solve an equation is to find the value of the variable that makes the equation true. There could be more than one true value, or there might not be any solutions at all. So you're going to undo the order of operations to solve equations. So you sort of work backwards through PEMDAS. So in the PEMDAS, we would add or subtract last. That's usually what we want to do first, and then multiply and divide to get rid of things. Work backwards through the equation. Changes must be consistent, and to maintain equivalent equations. That says fractions. That's actually equations. Must have been just a oops when I was thinking. So change fractions to equations. Sorry about that. So if you look at this little example here, an equivalent equation is where they're balanced. So if you look at this little picture, it's a rock or a bunch of rocks balanced on another rock, but it's level, it's balanced. Equivalent means same but different. So if you notice on the left-hand side of this balance, there's two rocks that are equally weighing the other side, the right side. So they don't necessarily have to look the same all the way through, but they're balanced. So whatever you do to one side must be done to the other side. Properties of equality. We have 4 major properties of equality right now. Excuse me. The first is the addition property of equality, so things are equal. And what the addition property says, if you have an equation that's balanced, equivalent, if A is equal to B, so again, equivalent or balanced because A is not equal to B, like they're not the same thing, but they are equivalent to each other. Then there may be a C value that if they're balanced, I can add a C value to both sides and it will still be balanced. That's what the added addition property of equality says. That if I have something that's balanced, if I add something to each side of that balanced equation, as long as I'm consistent, it will still be balanced. So I like to think of, if I have this equation, 5 is equal to 2 plus 3. It's balanced. 5 is equal to 5. They're equivalent but different. Okay, they both equal 5, but they're different. And if I take that equation, and let's just say I want to add 9 to both sides, I will still have a balanced equation. Because on the one side it's 14, 5 plus 9 is 14, and 2 plus 3 plus 9 is also 14. So in the end, we are still balanced. Each side is no longer 5. Each side has increased by 9, but still balanced, is still equal. Subtraction property is basically saying the same thing. If A is equal to B, then we could do the same thing. Subtract a common C value, and it will, as long as we're consistent and subtract it from both sides, we'll still have balance. So this is saying whatever I subtract from one side, as long as I subtract it from the other, they are still balanced. So I like to think of the same example. 5 is equal to 2 plus 3. If I were to subtract 1 from each side, as long as I'm consistent when I subtract 1 from each side, the left-hand side is equal to 4, and the right-hand side is also equal to 4. So not equal to 5 anymore, 1 less than 5, but they're still balanced. Multiplication just follows the same pattern here. If I have 2 sides equal to each other, A is equal to B, then if I were to multiply both sides by a common amount, they'll still be balanced. Okay, and so this is what allows us that if I have 5 equals 2 plus 3, and I decide that I want to multiply this entire side by 2, and I want to multiply this entire side by 2, as long as I'm consistent, this left side got twice as big, which is 10. The right-hand side, I can distribute the 2 if I wanted to. 2 times 2 is 4, plus 2 times 3 is 6, and you can see that we still have balance. It looks different, but in the end, they're equivalent. And last but not least is division. If I have two sides of an equation equal to each other, then if I were to take each of those numbers and divide them by a common amount, they would still be balanced. I want you guys to get in the habit of showing division as a fraction. This whole division symbol with the line and the 2 dots is sort of an elementary concept. Whenever we show division, we're usually, most of the time, showing a fraction, a ratio. Okay, and so as for my numbers with the example here, if I have 5 is equal to 2 plus 3, and I decide to divide this by -2 and this by -2, I still get, in the end, -2.5 is equal to -2.5. Still balanced, still equivalent, just half as much. Okay? So those are the 4 properties, those are the 4 rules of math that allow us to solve equations. Okay? So they're the name, they're the reason. We're not going to go through and say, well, why can we do that? But they are the reasons why. So in math, we always like to say the rules that we're going to use that allow us to do what we're going to do. Okay, so the biggest thing here is your workmanship. I'm really going to stress showing every single step. If you use a calculator, it gets written down on your paper. I'm going to strongly suggest using a calculator because your signs of positive negatives can get a little messed up. And if you do something in your head, it gets written down on paper. So in this case, right now, what's happening to H is we are subtracting 12 from H. That's a subtract 12. So to undo the subtraction of 12, I'm going to add 12 to it so that we get back to the additive identity of 0. When we solve, remember, when we solve, I want to get the variable by itself. So I want to get H all by itself. So I'm going to add 12 to the left-hand side. If I add 12 to the left-hand side, I also have to add 12 to the right-hand side. I'm going to show my line showing you that I'm going to do some math. So I want to see the plus 12, the plus 12, and what I'm going to suggest is drawing an arrow to drop down the H. Now you can put plus 0 if you'd like. Another thing you can do is just cancel out the 2 opposites. When you add 12 to a -12 or a subtract 12, it becomes 0. Line up your equal sign and then do the math. -27 plus 12. If you don't trust your mental math, this is where the calculator really comes into play. And it's -15. Okay, so I'd like you to put a box around that somehow so I can see that that's your solution. When we go to check our solutions, I like to put a little check mark, and this is me checking to see if I did this correctly. You always use the original problem, so we start with the original problem. We plug in our solution. I use parentheses when I plug it in so that my signs don't get all mixed up. And really what we're asking here is this equal? Will I get a -27 when I plug -15 in for H? And so when I do -15, take away 12, I get -27. -27 is equivalent to -27. This right here tells me it's true. The fact that -27 equals -27 tells me that my value for my variable is -15. My solution is -15. So my solution isn't -27, my solution is -15. The -27 tells me that that's the correct solution. Let's try another one. So we're going to solve for C. We're going to try to get C by itself. And so right now, I want to get C all by itself. Right now, I'm adding 36 to C. I need to undo that. I need to get rid of that. I need to make that 36 turn into 0. So using the additive identity or the inverse, I know if I subtract 36, it'll take it to 0. So I'm going to make this side 36 less. Whatever I do to one side, I have to do the other. This is that subtraction property. So I'm going to subtract 36 from the 102 as well. I'm going to bring down my C value. Again, if you want to put plus 0 or just cancel it out, try to line up your equations, your equal sign on each side. C is equal to 102, take away 36, which is 66. Put a box around it so you can find it. Neatness is what I'm looking for here. When we go to check our answers, make a little check. I always write down the original problem. Plug in. I usually use parentheses to plug in the value of the variable. And we're wondering, is 66 plus 36 equal to 102? And when I use my calculator, it is. 102 equals 102. That tells me that 66 was the correct value for C. So C is equal to 66. All right, for number 3, got some crazy fractions here. So what I'm going to do first is I'm going to make that mixed number into an improper fraction. So if you remember to do that, you multiply the whole number times the denominator. -1 times 8 is -8. Then you add the 3 to it. And so actually that's -11/8 k. You kind of leave the negative off of it until the very end. So when I multiply the 1 and the 8 and then add 3, I get 11/8, but because it was negative, it's a -11/8, is equal to 2/3. I need to see right now what's happening to my variable. I got to get k by itself. K right now is being multiplied by a fraction. I need that to be a 1k. It's being multiplied, so if I divide by -11/8, that's one way to show this. Divide by -11/8. A -11/8 divided by another -11/8 becomes 1 whole k. So you can put 1k or just k. You can use your calculator to figure this out. You can use the fraction buttons, 2/3 divided by -11/8, and you get -16/33. Okay, another way to do division, let me just show you. To show division of fractions, we could really say 2/3 divided by -11/8. Now, I just got done telling you to get rid of that symbol, except when we do fractions, we bring it back. 2/3, when you divide fractions, you really multiply by the reciprocal. And when you multiply fractions, you multiply numerators. There's your -16. And denominators, there's your 33. So that's one way of showing it. There's the second way of showing that. Another way we can make the k turn into a 1 is instead of actually using division at all with fractions, we know that we can make -11/8 turn into 1 using its reciprocal. So if I were to multiply this same problem by -8/11, by -8/11, I'm multiplying by the reciprocal. So I can divide by the actual fraction. I can multiply by the reciprocal, and this -8 and 8 cancel, this -11/11 cancel, left with 1k. And then this work right here is the same work I just showed up above here. So in a sense, the division turns into multiplication of the reciprocal anyway. So I just showed you 3 different ways to do that same problem. Okay, figure out which one you like. Okay, the blue work shows division. The red and purple work shows multiplication. The green here is just showing my work for the division. When I go to check this answer, I always start with my original problem. I plug in my k value, so -11/8, in parentheses, -16/33, and I'm just checking, will that eventually equal 2/3? When I calculate that out, negative 11 times negative 16 is a positive 176. 8 times 33 is a positive 264. I'm wondering if that is equivalent to 2/3. When I reduce that using my calculator, I get 2/3. 2/3 is equal to 2/3. Now, I can show you tomorrow how to reduce it on your calculator, but really what you're figuring out is that 88 goes into both of those numbers. So I divided 176 by 88 and got 2, and I divided 264 by 88 and I got 3. But there's an easier way on your calculator. Keep your answers in fraction form. It's a lot easier in Algebra 1 and the rest of your math if we keep our numbers as fractions in simplest form, not decimals. All right, a couple more here. Number 4 is the first time we saw the variable on the other side of the equation. So the b value is on the right-hand side. You can solve it just like that, or if you would rather have it on the left-hand side, you're allowed to flip it around because of the symmetric property that we learned about in Chapter 1. The symmetric property basically says you're allowed to flip these around. If negative 75 is equivalent to negative 15b, I can rewrite that as negative 15b equal to negative 75, and it's the same thing. That was that whole symmetric property from Chapter 1. Right now I want to concentrate on getting b by itself. It's being multiplied by a negative 15, so I'm going to divide by a negative 15. Whatever I do to one side, I'm going to also do to the other side, so I'm going to show my fractions division. A negative 15 divided by a negative 15 cancels and gives me 1b, or just b. A negative 75 divided by a negative 15 becomes a positive 5. So b is equal to positive 5. When I go to show my check here, I check my solutions, use my original problem always. I'm going to plug in my variable, and I'm just questioning, put a little question mark above there. Is negative 15 times positive 5 equal to negative 75? And in fact, it is. So I have my solution in blue and my check in red. A word problem here. Robert is driving 780 miles to Memphis. He drove about 3/5 of the distance on the first day. About how many miles did Robert drive? Okay, so what we're asking for is how many miles did Robert drive? Let's make m equal to miles. And we know that he is driving a total of 78 miles. And he drove about 3/5 of the distance on the first day. And so how many miles did he drive? 3/5 of the miles is equal to 780. So we know that 3/5 of the miles is equal to 780. If I multiply, I'm multiplying by 3/5. To solve this, I can multiply by 5/3, multiply by 5/3, and 780, if I make it a fraction, times 5, numerator times numerator is 3,900. 1 times 3 is 3. The miles total will be 1,300. The miles he has driven so far is 780. That's 3/5 of the total distance. How many miles did he drive? 1,300 is where he's going. Couple more, just be careful. We've got division here. So to show division, I'm not going to show my checks anymore, but the variable t is being divided by 7. So if I just show a times by 7 here and a dot 7 here, I'm multiplying both sides by 7. 7 divided by 7 is just 1t is equal to negative 35. Okay, not a whole lot of work to be shown there, but I do want to see the 2 7s. And then when you have a double sign, this kind of gets confusing. My suggestion is you're subtracting a negative. Whenever you have double negatives, though, a better way of saying that is just addition. So what I'd like to see as your first step is to clean that up. So instead of saying y minus a negative 5.6, we're going to say y plus 5.6. Subtract 5.6, subtract 5.6, and y is equal to 1.5, take away 5.6, negative 4.1. If you wanted to flip that around so that the y value was on the left-hand side instead of the right, that would be okay too. I'm not going to show the checks just for time, but the same thing. We could check these, plug them in, and make sure that they're correct. So the lesson summary. What does it mean to solve an equation? And solve and check the equation. Be sure to show all your work. I'm going to be looking for the entire formal solving and the checking process. Good luck.